Hi, this is Mrs. Cahill with our FSA review. Be sure to be listening with your headphones and try these problems before I do them whenever possible. On the first three problems, they're asking us to graph those functions. Remember that when we graph a function and it's in slope-intercept form like this, then we know that that m is the slope, and it tells us how we move. The b is our y-intercept, and that tells us where to begin. So clearly we would begin with the y-intercept, which in this case is 4. So on the y-axis, I will have a y-intercept at 4, and now I'll use my slope to move. My slope is a -3. I can put that over 1. To rise, -3 is really to fall 1, 2, 3, and run forward 1. I can do that again. Fall 1, 2, 3, forward 1. Do it a few times until you get enough points to define your line. Technically, you only need 2, but it couldn't hurt to get more. And add arrows to show that your line goes on forever. Let's try the next one. This time our y-intercept is not 5, it's -5. So on the y-axis, we plot our point at -5, and we use our slope to move, to rise and run. I'm going to rise 1 and run 2. Rise 1, run forward 2, rise 1, run forward 2. You could also fall 1 and go backward 2, and then connect that with your straight edge and add arrows. I want you to notice something. On this one I just graphed, the line looks uphill as we read from left to right. It is uphill and my slope is positive. This line looks downhill as I read from left to right, and that makes sense because my slope is negative. So on the third question, I want you to make a prediction. How will that line look? Hopefully you said downhill because our slope is negative. Let's begin at our y-intercept of 3. Our slope is a -2 over 1. That means I will fall 2 and run forward 1, fall 2, run forward 1, and connect that with a straight edge. Don't forget to add arrows. On number 4, they want us to find the missing angle, the measure of the missing angle. So we see we want angle X, and we've got a couple of things going on in this picture. I hope you've noticed that we have parallel lines. There's some math we know about parallel lines, and it is helpful when you have more lines than you need to cover up some of them. So let me cover up this one right here. I'm going to get an angle that I don't need as my final answer, but would be very helpful in getting the angle that I need. Do you see I have 2 parallel lines and a transversal, that's this line here, and I've got this angle 44. Well, I know this angle right here is alternate interior, and therefore also 44 degrees because alternate interior angles are congruent. Now let me remove that cover so I can see. Looks like I've got a triangle. In fact, if I were to pull that triangle out separately, and I could go ahead and put the 44 in here, and I'm looking for X, I hope you've noticed that we've got 2 remote interior angles and our exterior angle. Well, the deal is, if I add up the 2 remote interior angles, they equal that exterior angle. 44 plus 70 is 114 degrees. So that would be the answer to the question. That angle is 114 degrees. And we could put it in the original picture as well. Number 5, for what value of X does B equal 3? Well, you look at this complicated equation. It's got 2 variables in it, a B and an X. That's too many. We can't solve with 2 variables. However, they want us to plug in 3 for X. So that's exactly what I did. I took that exact same equation, except where I have B, I plugged in 3. Now this is something we can do. We've got 1 variable. I recognize that on the left side, I could distribute that 4, multiply both of those terms inside the parentheses by 4, and on the right side, I can divide by 2. So you try that first and see if your next line matches mine. Go ahead and hit pause. I hope when you did so that you got this, because 4 times 3 is 12, and 4 times negative x is negative 4x. And on the right side, 8x divided by 2 is 4x. Now I want to get my variables on one side. So we like to move the small one when possible. I'd love to get rid of this minus 4x. The opposite of subtracting 4x is to add 4x, and that's what I'll do to both sides. Well, those two cancel as planned, and we're left with 12 equals 8x. X is almost alone. We will now get rid of the multiply by 8 by doing the opposite. The inverse would be to divide by 8, but we must do that to both sides. And when I cancel, and of course the plan was that 8 divided by 8 cancels, we get x equals 3/2. I can write that answer as x equals 1 and 1/2. I could also write that as x equals 1.5. All right, number 6, we're going to evaluate these perfect cubes. We've got cube root of 125 and 64 and so on. But before we do that, let's talk about what the perfect cubes are. You need to have these memorized, so I would write this on our paper. When I'm talking about 1 cubed, 1 times 1 times 1 is 1. 2 cubed means, and actually I could be adding my cube signs here. Let's talk about all of these values raised to the 3rd power. And these notes I'm showing you right now, you could add this to the front of your packet. 2 to the 3rd power, 2 times 2 times 2 is 8. 3 to the 3rd power is 27. 4 to the 3rd power is 64, and so on, and so on. You're supposed to have those numbers memorized. However, on the FSA, would it take you very long to come up with that amount? Couldn't you do 6 times 6 is 36, then multiply that by one more 6. 6 times 6 is 36. 6 times 3 is 18, plus 3 is 21. And you could come up with that number by hand, and then it would be very helpful to perform these problems. So the cube root of 125, here's 125. The cube root is 5. The cube root of 64 is 4. The cube root of 216 is 6. Of 8 gives us 2. The cube root of 27 is 3. And the cube root of 343 is 7. For the next problem, number 8, we are going to find for each of these functions whether the following statements are true. Now, I find those statements a little bit cumbersome to look at. By the way, let me write my question so it looks more like yours. This line needs to disappear for a minute. So we want to answer those questions. I do want to look quickly at what they're talking about. They're talking about slope and y-intercept. So that tells me on both of these functions, I need to find slope and I need to find my y-intercept. Function A is from a table. Here's how we find slope. It looks like we go up 2 every time we go up 1. Up 2 every time we go up 1. So our m is equal to 2. Our b, we are lucky. They gave us our b. When we see our x value at 0, we know that we have our y-intercept, and it's 5. So I can write that equation easily. Y equals 2x plus 5. For function b, our life is actually a little bit easier because I can see that my y-intercept is at 4, and I can count my rise and my run. If I rise 2, I run 1. Or I think you might see it more clearly if I show that I'm actually rising 2, 4, and going over 2, so my slope is 4 over 2, but that just reduces down to 2. So I have my y-intercept and my slope, and I can write that equation. Notice the two equations are not the same. They have the same slope, but they have different y-intercepts. That's going to make answering these questions way easier. So is the slope of A greater for this first question? No. Is the slope for B greater? No, they're the same. Now let's look at the y-intercepts. Is the y-intercept for A greater? Yeah, that's a 5. It's bigger than 4. So the y-intercept for function B could not be greater. Is the y-intercept for both functions the same? No, it's not. The two functions are the same? No, they're not the same because M and B would have to match up for both of them, and they don't. The systems have no solution. Well, did you notice they are with the same slope and different y-intercepts? What we really have are parallel lines, and that is something you could memorize. You could also graph it. I could graph function A on the same graph as function B. I've got to give my y-intercept of 5, and then I have to have a slope the same as 2, so I know it's going to be parallel. And there we have it. Is that red line ever going to touch the black line? No. So we will have no solution. This one's actually true. If we have no solutions, it makes the last two false. We don't have one solution, and we don't have infinite solutions. So actually, I think the only two that we circled were those two. Question number 8. And we're only going to do part A for this one. We didn't do part B. Find the unit rate of just function A. Cross off function B. So unit rate. I hope you realize that unit rate is another word for slope. If you didn't remember that, on the front of your paper, could you write down that slope is the same as unit rate? That's important vocabulary. So let's get the slope. We can do rise over run. If I rise from this point to this point, I am rising 80, and I'll be running 2. From 2 to 4 is 2. So what do I have? 80 over 2. I can reduce that. It's 40 over 1. And of course, I could call that just 40. There is a slight difference. If this is unit rate, I need to add words. It's 40 what per what? 40 miles per hour. And that's how you would write your final answer. It's not just 40, it's 40 miles per hour. All right, number 9, what are the solutions of x squared equals 64? So I rewrote the equation. I need to get x alone. The opposite of squaring is square rooting, but if I square root one side, I must square root the other side. And I have to remember something else. This is algebra speak for we're going to have two answers. I need to add the plus and the minus to the square root of 64. And I get x equals 8. And it also equals -8. I don't want you to miss this on the FSA. This one has two solutions. Let's show why. We all know that 8 times 8 equals 64. But guess what else? -8 times -8 also equals 64. So that checks out. On number 9, what are the solutions to x cubed equals 125? If we write that out in the same fashion, the opposite of cubing is cube rooting, but I must cube root both sides. And the cube root of 125 is 5. Notice there's only one answer blank. I'm only expecting one answer. I do know that 5 times 5 times 5 equals positive 125. Does it work with -5? -5 times -5 times -5? That doesn't work. That equals -125. I don't want negative 125. It doesn't work. So there really is just one answer. All right, we're going to pause here. You can do the next video next time. If you're set, if you still have energy, go ahead and do some more. And good luck on preparing for your FSA.